Hello, everyone. Welcome to today's webinar. My name is Khalil Doheny, and I'm head of content at DNA. Today, we have Charles from Atombeam. Charles, how are you doing today?
Good, Khalil. How are you?
Doing great, doing great. Really excited for today's webinar. It is Atombeam's last webinar before the campaign closes. Charles, while people are coming in, is there anything you want to, start off the webinar with? You don't have to give a background on yourself. I'm sure people already know who you are. But if there's anything you want to start the webinar with.
Yeah. So I just wanted to, I think good point. I mean, I think, with things sort of coming to a close here, and I'm going to talk about this a little bit, but I think it's good for everybody to get a sense that why we're closing now, what's driving this. And it really, really comes down to my perception really of sort of two things both going up. One is sort of a perception that I have and others, and I think, the community here is getting a sense of, is that we're really starting to hit stride. Things are really starting to happen here pretty rapidly on a lot of different fronts. And as a part of that, we're also starting to get a lot of attention from institutions. And by institutions, I'm really referring to prospective investors, big prospective customers who could also be investors, C-level people at big companies, that kind of thing. And so, and then the final leg of this little thing I'm mentioning here is that to be able to address all that, you need institutional capital. And so I'll say it, never say never. We'll never go back and do crowdfunding again. I would say there's no intention to go back and do any more crowdfunding. And that's not because I don't like crowdfunding. It's just that, the numbers we need, we think are probably in the bigger numbers than we could generally do in crowdfunding. So, well, I really like the democratization of capital. I like the fact that we have a lot of sort of excited, interested investors who aren't big venture firms and stuff. I think we also have to look at reality and say, where are we really going to go? How are we going to get there? What are the resources we need? And that's really probably institutional capital. Maybe not immediately. But we're talking the fall or something, if I was going to guess. And to get there, we need more traction, and I think we're getting it, but it takes a little while to green it.
Awesome. And this is the last webinar during this for this campaign. So if you do have any questions throughout this whole webinar, please leave them in the Q&A chat box below. We'll make sure we're going to answer those questions towards the end. Don't want to waste any more time here. Charles, I'm going to pass the mic back to you if you want to go ahead and play your presentation.
Sure. Yeah. All right, here we go. So I have a little deck I put together, as usual. And basically, I just am looking at this as a chance to sum up. Here's what Atombeam is. Here's what compaction is. Here's where we are right now. Here's where I see it going. Just, not sort of like a really focused thing. Let's talk about AI or chips or something. It's very, very broad. And so with that, let's go. So in terms of like the order of things, going to talk about where we are right now in terms of this capital and what the plan is and the momentum we have, my view on compaction and why I think it can change the world, which I'm not kidding about it, and then sort of like where we see the company going. So let's talk about the raise first, and feel free to interrupt me anytime, Khalil. So let's talk about the raise first and generally money. So as I was saying, okay, so now we got 28 patents. We got this big Space Force contract coming in. We have, an Air Force contract, and we have a decent shot at getting one or two more phase twos from the Air Force. We have a lot of interest coming from the big, institutional investors. I get calls from major venture firms now and all that stuff. It's starting to really move. And we're going to have to bite the bullet and accept that we have to take in that institutional capital. And just to emphasize the last point, my job is to increase the value of people who have invested their money. And so what I'm trying to do is exactly that. And you got to recognize that at some point, okay, it's tens of millions, it's not ones of millions, and you need enough that you can hire a lot of people and do a lot of marketing and product management and all the other functions that bigger companies do to make this thing into what it can be. Let's talk about momentum. So this is both this big phase two that we got, and also our commercial profile. I mean, I get reached out like all the time. Like we had a long call with Intel this week. BMW reached out to us yesterday. We got Caterpillar reaching out. We have Schlumberger. We're in conversations. We just partnered with AMD, Xilinx, I think that's how you say it. At any rate, Inmarsat is working closely with us. There's a decent chance we'll get an investment from Biosat. Lockheed we're partnered with on this Space Force thing, on and on and on. So the point is that there's a time in the life of companies that you hope to get to. A lot of them don't, probably most don't, but you hit a point at which things are starting to tick and things are starting to fall in place, and you really feel the momentum. And that's where I think we are. So let me talk about DoD. I think DoD is a really, really big deal for us. And sort of like, but why? Why are they interested in us? In particular, Space Force. Space Force, they're the ones who serve the needs of Air Force and Navy and Army and Marines, everybody. And what they're doing is they're sending data from here to there. And they're also doing other things like, synthetic aperture radar imaging and things like that. But what we give them is the ability to replace, okay, instead of spending $10 billion on this satellite program to increase the capacity of their satellites, we can do that already. And I'm paraphrasing pretty much what the Space Force was saying to us. So once you get a phase two, as I've mentioned before in other contexts, phase two is a road to a phase three. I mean, you're kind of a made man when you get a phase two. And if you do your job and you look good, and they say, yeah, this is useful and these guys can do it and it really works in the context. I mean, they believe it works already. That's why you get a phase two. But to get it into devices and make it really work, you do that in a phase three. And the phase threes are 15, 20 million bucks each. And we could get multiple phase threes out of this phase two. So that's where you set things up to really deploy wide. And we deploy wide, and now that's not exactly small numbers. So anyway, so some pretty big opportunities coming up here. And it really, to break through in a phase two is what everybody is trying to do who's trying to get DoD business. So anything to stop on, Khalil, or should we move?
We have some questions coming in already. It's up to you, Charles. We can ask them now or wait towards the end.
If it's good in the context, then yes. And or if it's better later, happy to, whatever you think.
Let's go through the presentation and we'll save all the questions for the end.
Okay. All right. So another thing I get asked about a lot is the generative AI, and what impact could we have on that? And so I'm going to address it here. So just to be clear, some of the stuff we could do right now, and some of the stuff that I'm going to talk about here, it's going to take time and money and all that to get there. But the bottom line is that this kind of data that these generative AIs use is pretty much the kind of data that we do really well on. In other words, it's a lot of like text and stuff like that. And so we absolutely can shrink down the amount of it dramatically so that when an AI is pawing through all these files, it can find them a lot faster. It can put them on the actual AI in a lot smaller footprint. It can operate much faster. And it can search faster, it can randomly access faster, it can, and then longer term, when we get to in-chip instantiations, we'll be able to do the calculations faster that move data back and forth from the inter parts of a chip, that makes the chips themselves faster. And we're already talking to Intel about that, our partner Intel. So there's a ton of stuff that we impact. Some of it, again, we could do it today, and some of it is like make it smaller, do the access and search. But the really, really intensive thing is to move it into the actual chips themselves. And so the kinds of chips they use for AI, NVIDIA's chips in particular, can be made faster, we believe, with our stuff. So here's like an example of what it looks like. So this is a database file, human readable. This is the same information compacted. And so from a machine's perspective, it's the same thing, right? It can read it just as well, but it's a bunch of gibberish to a human. And that's because we have sucked out all of the repetition and the inefficiencies. And we've also, not by doing it, made it more secure, simply because the human can't read it. And trying to figure out how it was encoded, what the code book looks like that was used to encode it, extremely challenging. So bottom line is that this is how an AI, along with a lot of other things, but an AI in particular, would see a database squashed down to this much smaller form factor and much faster to access. It doesn't have to, it has to read over all of this data. And if the size of the data is way smaller, well, guess what? It's going to go faster. And this is like to show you how inefficient these, a typical IoT message is. And a lot of data is like this. So just look at these messages. And these are real messages generated by that gadget that say, here's the time, this is the model, this is the channel, this is the battery, this is the temp, this is the humidity, blah, blah, blah. Everything the same every time, except a different time by seconds. And sometimes there are machines that generate hundreds per second of these type of files. And so you add it up, you go like, really? I mean, and this is the best you can do? Well, the stuff on the right is really the best you can do, because that's what we do. So you can see how tiny it is compared to all that repetitive stuff. And we'll get down to in a little bit on how this affects an entire system. So that is where this is. Now, if you think about that and like how dramatically inefficient that is, that's everything. That's how all this stuff works. And that's frankly why compression works, because compression is squashing out all that stuff, but compression can't do the things that we do. It can't do it in real time. It's not searchable. When data that's compressed isn't searchable. It's a huge impact compared to, compression, which was left over. It's basically technology from the 1970s. And yeah, it's optimized and fast and everything, but it's fundamentally different. So if you look at this, you'd say all these things can be done in an entire system. And if we talk about how we'd scale compaction and make it work on everything, then you really want to get down so it's sitting on a chip, and either part of a chip as an IP core or an ASIC dedicated chip that just does this. That is really how this thing gets into the really big stuff. I mean, if you think about like how many chips like an airplane or a car or something has on it, hundreds. And most of those chips would benefit by having atom beam compaction on them. And if you think about how good that would be for us, well, that's pretty good. So, all right. And so, so what does it really mean in terms of like, impact on a real business? So I was talking at a conference a few weeks ago with the chief, Inmarsat's chief digital and commercial officer. And she said, we spend $1 million a day on infrastructure. That is to say, investing in things like gateways and servers and faster communications gear, all that stuff. She said we can probably not spend that if we had your stuff fully built into our systems, just because you squash out so much inefficiency. For a lot of people, just eliminating 75% of the cost of bandwidth is pretty significant. Longer term, making computers faster, just because the chips are faster, moving data between the chips is faster, and the entire infrastructure can be made faster. And she agreed with that. And we've got some pretty heavy additional people who agree with that assessment as well. It's really, really a sea change. So this is kind of like how we see the future. So, we have command line and we have a UI now, but, we need to make it much more wider. And we are right now working on putting ourselves into AWS as an option for somebody using IoT in particular. So I sign up, I want to use, I want to send my data to AWS or Azure, and I can use this compaction thing, and that will save me a lot of money on my transmission, or it'll make it secure, or whatever it is I care about. And now it's just a click the button. And we've been told by several multi-billion-dollar big companies that say if we could just push a button, this would be something we'd buy for sure. That's where we're trying to get to right now. We're working like beavers to get there. And that's part of why you need more money, because you're doing that. And then, of course, I already talked about the end game. On chips, big time important. I mean, right now we're focused on putting with an Air Force contract on an FPGA, which is a programmable kind of chip. And you can change the programming. The programming is, whatever. The programming, the FPGA is how a chip can be loaded with almost like a little operating system thing, like a little computer. It's got all the stuff. And you can change the code. So if we find, okay, we can optimize this, we have a bug there, all that stuff can get fixed. Then you move to permanent hardwired stuff, ASICs and IP cores. Those are, you can't change them systems. And that is how it builds, those things can be built into an entire system. So anyway, moving right along. And I'm just going to touch on this because it's not a full product yet. It's something that, again, another Air Force component we're working with and that's on how do we deal with images and video. So we're focused on sensor images. I mean, there's no reason why this couldn't apply to all sorts of video and imaging and stuff. But what we're doing right now is saying, okay, we're working with this, with actually the leading guy in the US for sensor image AI. And his AI is being combined with our compaction and this video codec. And we are putting together something that, according to the Air Force Research Lab, who are probably the most informed people in the world, that our stuff performs twice as well as anybody else's. And that obviously is a pretty major deal. So it's not a product yet, but one day when we talk about ASICs, it could be you buy an ASIC chip and it'll encode, the kinds of things that we encode with compaction. It'll encode your video and images, and it could even encode, audio. So you could have everything in one chip. Everybody wants to buy one thing if they can. So moving along, what are we doing from here? We're talking about like focusing a lot of the time and attention on these DoD contracts. We can go vertical just with DoD, but we're also spending a lot of time and effort on the commercial side, trying to turn these opportunities we have into revenue. We're really engaged there. We have a lot going on. But part of the key thing to get done, and we're working also hard on that, is getting ourselves put on the cloud. As I mentioned before, click a button, now Atombeam compaction works on your gadget and it sends it automatically to the cloud, and all you have to do is pay money. Yeah, we'll be selling like a lot of it, I think. And then in 2025 plus, we'll be looking for more phase threes, deployments, ramping our revenue, getting the chip stuff moving, in terms of hard-coded ASICs, IP cores. That is sort of like a broad sketch of where we take this thing. And the reason we can do all this is the things that this can do is, there's so many things that make this unique. If you were to say, well, what other things are like this? I would tell you there isn't anything like this. You can say, okay, well, what about compression? Literally none of these things are things that compression can address. And so one of the things that that is really important to understand here, or the most important thing to understand about compaction, is it's a new approach to data. It is a way that data can be handled, managed, moved, stored, everything in a much more efficient way. And, I've had some really genius level people who've said, well, I get what you're doing in this, and like the person at Inmarsat, she got it like that, and she saw the immediate impact. So, and sort of like, where are we now and where are we going? Yeah, okay, we're running around, we're focused on where we can get revenue right now, which is really focused on IoT data, cutting down the cost of it, working with Space Force on their kinds of things, etc. And then where we're moving to, and we're already doing some work, like I said, on chips and so forth, but where we're really moving to is making entire networks and on the logic board and all that, things to move faster. And then finally, when we're talking about entire systems that we're fully in everything, we have chips all over the place with our IP cores in them, etc. That's the big kahuna. That's where this goes. So, and I wanted to mention before we go that, put in a plug here, because our crowdfunding ends on June 29th. And so everybody here should know that. And Khalil, should I move on to the pièce de résistance, or do you want to answer questions first?
Let's go through everything before we go into the questions.
Okay. All right. Okay. So everybody hang on. Here we go.
Captain, we are receiving a distress call from the Space Force. Their satellite communication systems are overrun with data and they need help. They have to put out a general call for proposals.
Thank you, Lieutenant O'Hara. Mr. Chekhov, take us to Space Force headquarters. Warp 9, punch it.
Aye, sir. Stand by for warp. Warp 6, warp 7, warp 8, warp 8.5.
Captain, we need to slow down. I'm giving her all she's got. The dilithium crystals can't take it much longer. We need to drop out of warp so I can regenerate the matrix.
It's not good enough, Mr. Scott. Space Force needs our help.
I'll try, sir. Warp 9 it is. I can't tell you how long it will last.
Warp 9.
Mr. Spock, write a phase 2 proposal on compaction technology and prepare to submit it to Space Force.
Proposal complete, Captain. I made special reference to obtaining source words from a plain text source packet S by concatenation of substitutions via primary Huffman code of block length n and a mismatch code word m of length little m followed by concatenation of n over k substitutions via a secondary Huffman code.
Oh, sounds good. I agree.
You agree that the concatenation of n over k substitutions via secondary Huffman code is the correct approach?
Of course, Mr. Spock.
Captain, we are surrounded by startups who are competing to aid the Space Force. They are targeting us with their computer scientists. What should we do?
Don't worry about it.
There are thousands of them. It's like a drone swarm.
Captain, it appears that the startups are preparing their proposals. They're about to commence firing them at us to prevent us from reaching Space Force with a proposal for a technology that actually fixes their problem. I suggest we raise shields.
Shields up. Prepare to fire Mr. Spock's proposal.
Captain, there are hundreds of startups. I estimate our chances of success at 2.43%.
Spock, stop telling me the odds. It's going to work. Mr. Chekhov, load Mr. Spock's proposal in the photon torpedo tubes.
Aye, sir. Proposal on.
Fire proposal. Full spread.
Message received from Space Force. We have received funding for our phase 2 proposal, $1.2 million.
We made it again. Space Force is going to be Hawkeye.
Mr. Chekhov, take us into Space Force headquarters. Good work, everyone. And Mr. Chekhov, secure that 1.2 million.
General rejoicing.
Captain's log, stardate 2259.53. We've confirmed. The Space Force needs a way to massively increase their communications capacity and to increase security without spending billions on new satellites. And they think we may have the answer. We won't let them down. We're going to make everything they do better, and the crew is excited to make that happen. Speculation. We may be able to improve transport beaming efficiency too.
Okay. All right, well, I hope everyone was amused, it's, one of those things. You gotta have, everybody gets, excited about things, about, doing stuff, and it's a good team building thing, so, but we got real competition here. Who is the worst actor, right? We're working, I know a lot of us are gonna be disappointed, but, we really tried to be, well, I can't say we tried to be bad, but that's the way things work out. So anyway, so come in and vote and let us know. And by the way, for anybody who was confused, this is not a trailer for the new Star Trek movie that they're still working on. So
Yeah, we'll give the poll a couple of minutes. We'll just go jump into questions, and then after the questions, we'll see who the winner is. All right, first question here is, will you continue to provide the excellent updates to this community after the close?
yeah, absolutely. I've actually already talked with Khalil's group about it, and we can, we won't spend money on advertising, but we'll keep doing updates, and I'll have webinars and all that. So yes.
And how will Atombeam's pending patents be different from your competitors?
Ah, well, if you could tell me who the competitor is, if we had one, which we really don't, then I would tell you. But we've had some really heavy duty guys, who understand patents look at our stuff. We've had people who really understand technology look at our stuff. It's a very, very tough thing to tell you, because it's just such a new thing. It's such a fundamental thing. It really is. I mean, you could say, okay, well, what about compression algorithms? Yeah, okay. Okay. What about them? I mean, yeah. And eventually, I think it's certainly possible that they'd start to get, some compression algorithms may be able to start reducing the size of smaller datagrams better than they do. But that doesn't mean that they are going to get, that, I mean, what I'm saying in essence is all the other things that we do are NA when it comes to any kind of compression at all, simply because that's the way it works.
And how many of the patents are issued versus pending?
Oh, so yeah, so parsing it out, we have, I think it's 19 of the 28 are actually issued. The rest of the 28, are allowed, and that means that we have a notice from the patent office that as soon as we pay the fee, they will issue the patent. That's pretty much the way that works. And then for the then the other patents, I think there's 12 that are pending at the moment, but we're always cranking on those patents. I mean, there's a lot of patents, and and it's hard to even keep them track, but that gives you a sense.
Do you feel the tens of millions will come quickly and easily after the close?
I mean, I don't want to, it depends on what you mean easily and quickly. I would say we have tons of interest. I would say that, I mean, I'll put it this way, when someone calls me right now, I don't say I'm in the market to raise money. And if they do, say, well, we're interested, I say, well, I'm looking for money in the fall. Because we don't want to raise, large institutional money right now, because we wouldn't be optimizing the outcome for us. We wanted to get enough money in the bank that we could say, okay, we're good now. Let's close some business. Let's ramp up the valuation. Then we'll raise that institutional money. Exactly when that is, not now, but sometime pretty soon.
And would phase 3 consist of more testing / POCs that would cost 15 to 20 million to execute, or 15 to 20 million in recurring revenue?
Yeah, so it's sort of like neither. So POCs are really, I mean, really what a phase 2 is it's prototyping. It's saying, okay, we don't actually have to put it on the whatever it is. Like, say it was going to go in F-35, say. And so we look at the data that the F-35 generates, different data types. We'd optimize around that. We do all sorts of testing and all that stuff. And on that basis, there is, we would basically prove that it does work if it was in this F-35. And in the phase 3, you actually put it in the systems of an F-35 in whatever format that is. It might even be an FPGA, for example. It might be loading in the software stack. But that's the stuff that you drill down on and demonstrate in that.
And assuming you start to get some meaningful revenue from, say, DoD and Inmarsat in the next 12 to 18 months, what will the financial model look like, re-gross margins and pre-tax margins?
Yeah. Well, I mean, we're a software company, and we also are not a consumer kind of software company in the sense that we have to have a lot of support people and a lot of, infrastructure. So basically, we just need to build the software. And we also are a product that gets put into other things. So if you buy a satellite terminal or you use a satellite terminal that's built by Hughes, say, and distribute and sold to you through a distributor, we would be in what's called third tier support. They would support that, all the other, us and the other software and the hardware. And then if something gets to a level where they can't answer the question, then they move to us, which means, sorry for the long explanation, but it means that we don't need a whole lot of infrastructure or people, which means that 85% is a pretty reasonable assumption in terms of a gross margin. And then also, we think that, pre-tax will probably, I hate to put out a number, but it's not unreasonable. Put it this way, most people believe that most people believe that we would have a pretty small sort of set of requirements for the numbers of people generally, which is main cost. So 40% pre, not unreasonable.
And what is the current team size of an engineering department?
So in terms of full-time dedicated engineers, there's 3. There's a requirement, a head count for 1 more that we are looking for right now, and plus the CTO. Plus Josh, if you want to count him as an engineer, he's the chief science officer, and he's really a mathematician, but he does do coding and so forth, just not sort of like he's prototyping more than the final product coding.
And is there currently enough funding to see the Space Force Phase 2 opportunity to get to Phase 3? That is enough runway without further raising?
Maybe, but I would say that we would be robbing Peter to pay Paul if we don't look for more money, simply because if you said, okay, I can't answer the bell on something, on, if I can't, I just don't have the money it takes to do the things that we need to do to, like, okay, here's an example of what I'm talking about. There's one of the distributors for Inmarsat needs us to port our software to an operating system we've never ported it to. If I have not enough people, what I have to do is pull somebody off a Space Force project or working on the core or doing the automation or with something, so that if you do that, then you're saying, okay, sorry, I'm not going to be able to address this. I'm going to address that instead. And so we need more money to be able to do everything that we can do.
And for this next question, Charles, I'm going to send it to you directly. It is pretty long, so just wanted you to take a look at it.
All right, hang on. Yeah, so generally the question is, like, in the early going, we had bonus shares for early investors. And we also, there's also size bonus. So, I certainly have a lot of sympathy for the problem of, okay, I want to put in bigger numbers, but if I do that, then I think I should get, a bigger bonus than just the size bonus that's in the offering. I can't do anything about what the offering is now. It's SEC, it's filed with them. You can't make exceptions. You got to do exactly what it says, etc. It is what we do sometimes is we do private placements under an SEC exemption. And so I would say that anybody who's interested in investing the bigger numbers, you can write me. And if we do an offering, a private placement, I will let you know and send you a private placement memorandum. But the thing about those is you can't advertise them. You can't go out and wave your arms and say we're doing it or anything like that. You have to be very careful because SEC rules, that's under the exemption, you got to have people who are called accredited investors. They hit certain marks in terms of net worth or income and so forth, and you can't advertise it. So if you want to invest bigger numbers, let me know and I'll put you on the list and I'll let you know when we do a private placement.
Now the 28 patents worldwide coverage?
In most cases, no, just because, and this is the advice of our patent guy and other patent people. All of our stuff would be widely applicable to, would be mainly be used by companies that would use them globally. And if you exclude the US market, it's very expensive. Put it this way. If we did what's called national phase with putting it into a lot of other places, we would be, we would have money. The money would be gone really quickly and we wouldn't have nearly 28 patents. And so if you add it up, you'd say, okay, is it better to have 6 or 7 patents and have global coverage or have 28 and US coverage? That's what it boils down to. It's, it's a resource trade. Sure, if we had all the money in the world, then will we file everybody error? Yes, we would. But we feel strongly that we're in good shape covering everything in the US, and we have a core patent that we filed in Europe. So we're doing the best we can within the constraints of the money we've got. And we think we're in pretty good shape. And then that's not me, that's experts telling me.
This isn't a question, but a comment. Just wanted to say thanks for the opportunity, Charles. And don't forget about us little guys when you're out making it big in the world.
Right. Yep. So I'll invite you to Chateau de Chasselet and have someone peel a grape for you. Right. So, right. So, I would say this though, seriously, we did have options other than crowdfunding. And and it was advocated to me by a guy that did really well in it. And I said, I like this. Now, some of you probably know I'm a Wall Street guy. I was a Wall Street guy a long time ago. And I kind of know how all these institutional guys work and how it's an inside game, it's like, and most guys who have, 500, $1,000 or whatever to put into a thing have no chance to see a company like Atombeam. It's just not going to happen. Why? Because this big shot and that big shot, they are, they're the ones who get all the opportunities. And I just said, I just don't like that. I like the idea of giving, people, opportunity, because I think this is going to be a really big deal. It's my opinion, no guarantees, yada, yada, but I think this is going to be a big deal. Somebody told me the other day, this feels like, and this is a guy, actually a developer at Google, who said this feels like Google in the early days. And so God knows, I don't want to make any advertisements that this is going to be Google or something, but it's got a lot of, I think this has legs, and it's just, and so we take it to a point where we can with crowdfunding, and then we move on just because we have to.
And how long until we are available in AWS, and how long do you think until we finish the phase 2?
AWS, we're working on that right now. There's going to be stages. So the stage where you click a button and it pushes out that thing and gets everything all set and everything, that is going to be end of the year, maybe early next year. To get to the point where you have it, okay, I've loaded into this box and I have it on AWS too, and I just need to turn it on AWS and everything will work. That will be, I don't know, probably they should have it up and running, and maybe not selling it yet, but they should have it up and running within a month or two. That's what they're telling me, which means like 2 to 3 months. Because that's the way engineers are, you know. So at any rate, so the bottom line is we're not far away from making that happen. And then Azure, we can do pretty much right now. We do it through Crosser because Crosser sort of forms a whole nucleus of everything that needs to happen in Crosser. They're really Crosser centric. That's our partner that's kind of like takes care of all the moving the data around and putting us into things and monitoring it and everything.
I can't invest in Atombeam right now, unfortunately. Will I be able to invest in the future before Atombeam explodes? Because I believe you will. I know you talked a little bit about that earlier. If you want to go in a little deeper into that.
Yeah, so I would say that, you know, there's no, you never say never. You don't say there's no way we'll ever raise another crowdfunding round, because who knows, you know, things change. We say, you know, well, I think it's better to wait a little longer before we go get the institutional money, because we can get a lot bigger pre-money if X or Y happens, and X or Y needs, you know, we need to raise another million or something. So yeah, and then we go back, and crowdfunding would definitely be on the table. I think, you know, we would, part of it is I like doing it, you know, I'm probably weird that way, but I kind of like just, you know, doing this and talking to people and having interaction, a community and everything. So I would say it's not impossible, but I would definitely not count on it, because as of right now, there isn't a plan to raise any more crowdfunding there, you know, and it's not anything other than, you know, if we're going to put this into chips and we're going to have, you know, serious infrastructure and people running around, I mean, you got to have enough money to hire the, you know, all those people and make it really work.
And then how do you see VC funding impacting current investor dilution?
Yeah. So I will tell you that I don't know that we're going to get VC funding, because I don't necessarily want VC funding. And it's not that, I mean, I really think we'll have options here pretty soon for VC funding, and we probably do now. I just haven't pursued them. But I personally, you know, not, I mean, and I should be circumspect because a lot of my classmates from business school are venture guys, but I'm not a big fan of taking money from venture. Now, there are some that really are great and add a lot of value and everything, but I think that, I mean, the scenario I like would be to go out and raise money from you know, at a very healthy valuation from one or two strategics, and you go out and you say it's Viasat. Viasat could say they put in a couple million, and now you go out, and I'm not saying they will, I'm just saying, okay, let's say they did. So they go out, and so we get that when it becomes our cornerstone investor, and, you know, stamp of approval, whatever you want to call it. Then you go in the market and you go to the people that fund the venture guys, as opposed to going to the venture guys, because the venture guys, they add a cost. they have their carry, they have their management fee, they have, they're negotiating to take as big a chunk as they possibly can. Whereas if you think of it like an investment banker thinks of it, I'm going in the market with an offering, and here's the terms. Are you interested, Mr. Pension Fund guy? Are you interested, Mr. Life Insurance Investment Management guy? Are you interested, Mr. Hedge Fund guy? And they are or they aren't. And if they are, you raise money on a non-control basis, and you raise money at a much better valuation, and you're not giving away the store in terms of valuation, in terms of, like, okay, you do a deal with a venture guy, and going forward, they'll decide everything. We want to sell the company. We have this big offer. No. We want to go public. We think this is a really good time, and Morgan Stanley says they can do it. No. They can do whatever they want. And they have essentially veto power at the least, and usually pretty affirmative set of powers too. So in terms of what would happen, all I can tell you in terms of dilution and stuff is that if you take in venture firms' money, you're getting preferred stock. Preferred stock has all sorts of bells and whistles and advantages and all this stuff. They could say, okay, well, we're doing another round now. We don't need it. Well, we're doing another round, and we're putting in the money, and here's the valuation. By the way, I hope, I hope you like it, because you don't have really a choice. And so that's the kind of thing that puts you into a bad position. Whereas, right now, everybody here who's invested is in the same exact security that I'm in. All right. We all own common stock. That's it. We don't have any preferred. We don't have anything. And so if we can avoid the venture guys, and I'm not guaranteeing we can, but if we can avoid them, I'd like to avoid them. And even if you take in preferred, it still can be fine. It just depends on who you're taking it from and what the terms are. And I would say to everybody, I've been there, I've done this, I've been in this, I've been on the other side a lot, having been an investment banker. You can count on me to cut a pretty good deal for everybody. And you're getting the same deal that I am.
After the SE raise, what would the tens of millions be used for from an institutional investor? Expanding the team?
Yeah, it's expanding the team, and it's a lot of things are like, okay, you want to put it on a chip. Well, you got to hire some specialized people in a specialized company that does just that. And you've got to, that's when you're forking over some big numbers to people. It's putting it on chips. It's a big cost. And you also have to say, okay, what are the other things? Well, you have to have people to sell it. You got to have people to support it. You've got to have more engineers. One of the cool things is we don't need nearly as many engineers as like a company with huge code bases. We got a tiny code base. It's going to get a lot bigger, because when you add all these automation things, it gets bigger. Not the thing that's executing, it's called the executable in a chip or on a device or whatever, but the thing that creates the code books and does all the automated stuff and everything, those will get bigger and bigger and bigger. But it won't matter because it sits on a server somewhere and everything. So what it really comes down to is it's all the things that a software company needs. It's just that we don't need as many things as most software companies, because you're not calling Microsoft and getting support, right? You're not, we're not dealing with consumers. We're not dealing with lots and lots of folks that are just not, we're back in third tier support in most cases. So anyway, so that's what we're doing. That's what it's spent on. Typical software things.
If we got contracts worth millions, could we bootstrap instead of getting funds from institutional?
Yeah, yes, but there are, and I hear you, and I think about that a lot. But it really comes down to what's the best thing for shareholders. What the best thing for shareholders may or may not be taking in capital. And if it's taking in capital at not a good enough valuation, yeah, then it's better to wait and just wait until you get money and revenue and use that to expand. But in bootstrap more, sort of bootstrap. I mean, we've taken in a lot of capital here, but I would say that it's not just it. What it comes down to is, yes, we would take in money here when it's the right thing to do. Just, I mean, it's hard to be more specific. But if we were to say the big kahuna is to get into chips and have chips hard coded with our stuff, ASICs and IP cores, there's just no way you can do that quickly with waiting for the revenue to show up. Won't happen. And if you said, if I'm going to get, the sooner I can get to that place, the sooner the Atombeam is worth billions. Well, I think it's probably a good idea to take in, 10, 20% dilution, if that's what it takes.
And what percentage of future revenue over the next 24 months will come from the commercial cloud revenue stream? And do you see that sales revenue generating in the ones or tens of millions? Thank you. We've learned a tremendous amount about growing company. Charles, you rock.
Oh, cool. Thanks. I didn't hear a compliment about my portrayal of Captain Kirk, though, which it'd be fine if you want to add that. Anyway, so at least I did win the worst actor award, it looks like. So at any rate, what the heck was the question? I went off the rails there.
No
What
worries.
was the question again?
Let me pull it up.
Sorry.
No worries. I just have to. Where is it? Okay. What percentage of future revenue over the next 24 months will come from the commercial cloud revenue stream?
Yeah.
Do you see that sales revenue generating in the ones or tens of millions?
Oh, I think that, you think about where the billing would actually be for our stuff. So one is like, okay, a license fee when someone puts us in a chip, right? We get something. And I don't know if it's going to be 10 cents or $1 or something. And it's hard to tell at this stage. Too early to really say definitively. So that's one big source of revenue. And if you're talking like, say it's put in billions of chips, well, it adds up. The other big source, as I think down the road, is going to be, yes, it's going to be when someone's sending data to the cloud. So somebody sends data from, they're sending data to AWS or Azure or IBM or Google or whatever. That data, where that goes is, most people are going to be sending data there. In the most convenient way for them to be paid, us to be paid, them to pay, is going to be through the cloud providers. So I think that, there's no way it's ones and there's no way it's tens. And beyond that, I've got to be careful because I got a DSCC to worry about. But, I think that's going to be a very substantive part of our revenue.
And we are coming here at time.
Right.
We do have, a couple questions. Brian says we can send you to our friends at Legion M for acting. And then James also says, was that your future Super Bowl commercial?
Well, I'm already getting calls, all right, the Hollywood is on me, and, right, so anyway, but I'm really glad everybody joined in here. I appreciate the participation. I appreciate the questions and all that. And I also appreciate that I didn't win worst actor. So, Ashgar, congratulations, dude. I actually, can sort of understand that.
Charles, what is the last thing you want to tell the audience here before we sign off?
Yeah, so I would just emphasize, I don't want anybody to sit around and think, okay, well, they're probably going to reopen another crowdfunding. Maybe, maybe not. But I really, really want anybody who can and wants to invest in the round now, because no guarantees. But anyway, thank you. And the other big thing I want to say is thank you for everybody who's invested, who participated, who came on, who's listened, who paid attention, because, and tell your friends and everything, we're going to be a big deal, I think, and you're going to be part of it. So thank you very much.
Of course. Thank you, Charles. Thank you, everyone who attended. Like always, this webinar has been recorded this whole time. We will be posting a full recap on the Start Engine page. So if you want to rewatch it, or going to watch it for the first time, check it out on Start Engine. Thank you. Hope everyone has a good rest of their days.
Okay, very good. Thanks.